My name's Alyssa Kendall. I'm the chair of the Energy Graduate Group here at UC Davis. And it's a pleasure to welcome all of you guys to our virtual open house. So I'm going to get us started with a welcome and review of our program. And then I'm going to hand it off to Professor Alan Meyer, who's the chair of our admissions and recruitment committee. And he'll then pass it to a number of other folks, including myself, to tell you about the research that we do here at Davis that is related to the graduate group. And then you all who are logging in here will have an opportunity to talk with current egg students and alumni and ask them questions without the presence of faculty and staff. So you can ask them whatever you'd like to know. So as we do every one of our seminars and gatherings, I wanted to start with our land acknowledgement. We should take a moment to acknowledge the land on which we are gathered. For thousands of years, this land has been home of the Patwin people. Today, there are 3 federally recognized Patwin tribes: the Kachil-Dihi Band of Wintun Indians, the Calusa Indian Community, the Quetzal-Dihi Wintun Nation, and the Yocha-Dihi Wintun Nation. The Patwin people have remained committed to the stewardship of this land over many centuries. It has been cherished and protected as elders have instructed the young through generations, and we are honored and grateful to be here today on their traditional lands. This is for those of us located in Davis or on campus. I encourage all of you in other places to consider doing some research about the traditional lands on which you reside or work. With that, I'd like to tell you about UC Davis to get us started. So UC Davis is at least famous around here and in California for being the ag campus of the UC system. And so in 1908, we were founded as a university farm. And in 1922, we started offering 4-year degrees. And then in 1949, graduate degrees. And in 1959, we became a complete campus, moving away from just an agricultural, sort of an engineering and technology campus to being a complete campus. In 2017, the next important thing to have happened in the UC Davis history, and that is sarcasm you're hearing right now, but we actually welcomed our first Energy Graduate Group or EGG cohort to campus. So the Energy Graduate Group is reasonably young relative to other programs here on campus and a lot of other programs you might see at other universities. So what are we known for as a campus here? We're known very much for sustainability. We have really strong presence in the environmental sciences, along with engineering and some cross-cutting areas like transportation, energy efficiency, ecology. And we are particularly famous in the realms of agricultural research, so including things like fighting world hunger, and have a really strong record in veterinary medicine. I have to admit, veterinary medicine is one of the few places on campus that we probably haven't worked too closely with in energy, but we have worked with cows before. So, so we are able to collaborate across all of the wonderful departments and programs that exist here in Davis. Some of the other stuff to know about UC Davis: we're located in Davis, California, and we're the bike capital of the US. One thing to know is that in Davis, you can ride your bike and not actually have to ride on roads. We have a lot of bike infrastructure, and a lot of students find that they don't even need a car to get around. In terms of where we are, I'm not sure how many of you who have logged on are from California, Northern California in particular, but we are located kind of between San Francisco and Sacramento and the valley in between, and we're surrounded by a lot of agricultural fields, and we're an easy trip to the San Francisco Bay Area or the mountains. But I think equally important, or more important for a lot of the experiences our students have, we're right next door to Sacramento, and Sacramento is the capital of California and thus the policymaking center for the state. And California is famous for its very innovative energy and sustainability policies and policy making. And increasingly also it's getting more famous for some of the startups and other kinds of organizations and companies that grow from that activity. Some of the key agencies that we work with and that you'll be exposed to if you choose to come to Davis: the California Energy Commission, the California Air Resources Board, and a suite of other agencies and NGOs that actually sometimes fund research that we do and certainly inform the research that we do, and often provide internships and other kinds of experiences for our students as well. So what is the Energy Graduate Group? So we have this funny term that I'll talk about, graduate group, but basically the Energy Graduate Group came to be because we recognize that there's this challenge in the energy industry in California and all around the world, that there's an unmet demand for professionals in the energy sector that have the interdisciplinary graduate training they need to really solve energy related problems. So our mission is to produce energy leaders and experts in government and the private sector and academia, just about any place that energy is important. And we do this by, creating a truly interdisciplinary educational experience, trying to provide as many hands-on education and training programs that we can, and definitely preparing students for professional life after their degrees. And that may be, working in an agency or in an industry, but it might also be for in research or academic research as well. So we offer both master's and PhD degrees in energy systems. Within those 2 degree areas, you can concentrate in science and technology or management and policy. We have over 50 affiliated faculty from across UC Davis. And we designed our curriculum and our degree requirements to provide flexibility so that students can really get the knowledge and training they need for the specific problems they're interested in tackling. And part of the reason that we exist is that we know for energy problems that traditional departments in a university aren't really designed to help us solve the big energy problems that we face. And one of the things we want to deliver on is an energy program that really trains people in the technical and scientific space that they need to understand in order to tackle energy problems, but also the social, economic, and political perspectives that are really important for making our energy system more equitable and more sustainable. And so some of the ways that we do this, for example, we've embedded energy justice in our curriculum, and we've really think about people, even when we're talking about technologies and things, we're thinking about people and outcomes for the environment and human experiences. So trying to really bring a more holistic perspective about what the energy system really is about. And one of the examples that we've used in the past to talk about this is thinking about how an innovation in material science, for example, could lead to much more efficient solar panels, but increasing access to affordable and clean renewable energy around the world is not just a problem about material science, right? It's a problem that has to draw on lots of other knowledge and sectors as well. So this graduate group thing I've said a few times, this is kind of special to UC Davis. We have this policy where we give graduate degrees not specifically from a department but from a graduate group, and we do this so that we can bring truly interdisciplinary education and experiences to people. And we've been doing this since the 70s. This isn't like an invention since it's trendy to say interdisciplinary. And most of our graduate groups are departments or disciplines. They're traditional departments or disciplines, but there are some really important ones that aren't. So obviously the energy graduate group is one of those. We also have a kind of a sister program, the Transportation Technology and Policy degree program, which has been around since the 90s. And that also tries to address transportation problems, not just from an engineering standpoint, but the broader standpoint that we need to understand to address transportation problems. And then we also, and so these graduate groups, the energy and transportation, live in their respective institutes. So the EGG, the Energy Graduates Group, lives in the Energy and Efficiency Institute, and the TTP, the Transportation Technology and Policy Graduate Group, lives in our Institute of Transportation Studies. We are unique on this campus. The rest of the graduate groups all have a home base somewhere in a department, but they often, like us, draw on lots of different faculty from across the campus. And ecology is one of those. It's a very famous program the world over, and it basically has faculty across different colleges and across the whole campus, but still is housed in a department. So that's, some of you guys don't care about that, and I totally understand, but I don't think you're ever going to come across another university where you're going to be applying to a graduate group instead of a department or program. So I want to make sure you guys understand what they are and why they're valuable. In terms of our faculty, like I said, they come from all across the campus. And this includes departments in the College of Engineering, like civil engineering, where I am housed, and mechanical and aerospace engineering and material science and engineering, but also from other colleges, including the College of Agriculture and Environment. So we've got folks from the Agriculture and Resource Economics Department involved, Land, Air, and Water Resources, the Department of Human Ecology, which is a pretty broad department, but includes folks who work in fields like geography, from the economics department, and so forth. I'm not going to even name all of them. I know that we actively have 16 different faculty involved in advising students, and they are spread across all 3 colleges here at UC Davis. So one thing that I think is unique here at Davis is that you're going to have access to a lot of professors like me, like many of the other faculty involved in the program, and we're going to help connect you to the academic community. And you also will have other experiences that are designed to help connect you to the professional world a whole lot. So you're going to have a lot of opportunities to connect with experts and leaders from both the private and public sectors. And I love this comment. You can see Sacramento from UC Davis. I can attest that our students work really closely with policymakers and agencies here in California that are deploying and making policy happen on the ground. And then we have very specific experiences that are help you connect. So I'm not going to talk too much about this, but we have this orientation called Power Trip, and it's not like a normal orientation that you would have to orientate yourself to a university. It's literally, in fact, virtually over the past 2 years, but taking you to all of the agencies, the utilities, the NGOs that are important in the energy space, and connecting you guys and getting you all up to speed on what's happening here, and who you might need to connect with to continue developing professionally even after you're done with UC Davis. We've also have a fall seminar series, and I encourage you, if you're really interested in our program, go check out the recordings of, see who's spoken, pick a few that you really like, and listen to them and the questions that come afterwards, so you get a flavor of what that seminar series looks like as well. You'll see people from agencies, people from other universities, some industry leaders, just a whole suite of different folks that we bring in to talk to you about the energy system and energy problems. I also wanted to focus in on some of the particular focuses that we have here at Davis, and in particular in the energy graduate group. And one of those things is making sure that diversity, equity, and inclusion is embedded both in the way that we educate, but also the culture we try to inspire in our graduate program, and of course what we teach. And this statement was put together a few years ago, really led by students in our group that really want to think about creating an equitable and inclusive environment within our program itself, but then make sure that perspectives of racial, ethnic, gender, and sexual identity, equity, and justice in how we research the energy system and how we view it when we're talking about it and learning about it. So we have a really active diversity, equity, inclusion committee, and it's really student driven. Obviously, faculty are enthusiastically participating, but we want to make sure that this is student led. Alan, can you mute one of you? Yeah, thanks. Okay. So I'm almost done with my part of this, but I wanted to give you a picture. It's a little outdated. It's pre-COVID, but give you a picture of where our students have gone since graduating. Now, remember, we're a pretty young program, so this reflects just the first cohort of master's students finishing up and leaving. But we saw folks move into the private sector, the nonprofit sector, the public sector, meaning government agencies, and a little bit to academic outcomes as well. We're just seeing our first PhD students graduating. So any of you here who are interested in pursuing a PhD, we don't have much to tell you yet about where they're going, but I can say that at least one of them has a postdoc, and that we'll see where the rest of them go as they finish up. So our first group are just finishing because they came without master's degrees, or we had a few come with master's degrees. They're the ones who have finished, but we have a whole a whole another cohort of who came without master's degrees in 2017 and 2018, and they're just getting to the point where they're finishing up their dissertations and moving on. So we'll see where they land. But you'll see we have a big breadth in terms of where our students are landing. And at least prior to COVID, we saw them sort of moving into, the coasts basically around the US and finding jobs there. Okay, so I'm going to hand this over. I think Alan is up next.
That's right.
To talk about essentially applications.
That's right. I'm Alan Meyer. Thank you. Alyssa, can everybody hear me? Alyssa, can you just confirm you can hear me?
Yep, I can hear you.
Thanks, Alyssa, for the introduction to the Energy Graduate Group and UC Davis. I'm going to talk about how you actually become a graduate student in the Energy Graduate Group. First, we're going to talk about application requirements, because that's the most important step in getting here. You have essentially a checklist. You need to apply to EGG. And on this PowerPoint, you can see where that takes place. But in that application, you have several key pieces of documentation of your skills and your background. And we need to have those in order to know that you are a suitable candidate for the Energy Graduate Group. And this is where you're going to sell yourself. So you need to have a statement of purpose, and you need a personal history statement. And you need to have the transcripts from the universities and colleges that you've attended. And you need a resume or some sort of CV. It's not absolutely essential. I shouldn't say you need it, but it helps. In a way, a resume is a very effective way of summarizing your career to date. So we really appreciate that. It gives us a view of you that's more than just your transcript. But it also gives you a chance to describe or make us aware of some of your creative accomplishments beyond just the dry elements of your educational and professional backgrounds. So you could, in your resume, put in some links to some reports that you've written or some essays that you've written that will help us understand a little bit more about you. And especially if you have some essay or some report or something that you've done, it could even be a video, we'd like to be able to access it and learn more about you through those kinds of files, documents, media, whatever. There is going to be 3 letters of recommendation, and that I know is maybe awkward for you to get, but you work with people, your former professors, maybe your supervisors, other people to give you letters of recommendation that describe you, and it doesn't necessarily need to be all academic. It can talk about some other aspects of your life, but people who know you well and can assess you are most appreciated. We are still waiving the graduate record exam, the GRE, so you don't need to get that. If you are from outside the United States, you need to take the test of English, and you can find more about that later. Finally, I'm sorry to say you have to pay for the application. It's $120 for US students, $140 for international students. However, there are some ways to get around that. And maybe, Anne-Marie, can you advance the slide one? Thank you.
You still have control. Okay.
Oh, you have it. Good. The application, there is a way of waiving the application fee, and the only problems are that it applies only to US citizens or permanent residents, and if you're applying to a PhD. But look and check the fine print here, but there's a link to it, and it's at least worth your time because you could save $140. So next slide. I'm not sure why I'm not going here, but anyway, Here's some more information about application fee waivers. If you have any questions, honestly, you should talk to Anne-Marie Schaff, who will explain to you a little bit about the details of these methods to avoid to get your application fee waived. The deadlines. This is really important. If you don't make these deadlines, you may end up not getting funded or not even being accepted. So if you want to get a fellowship or you want to be considered for a fellowship, you must get your application in by January 15th. And that deadline is important for a couple of reasons. First of all, if you get your application in by January 15th, you will in general get priority review for both for admission and finding funds for your financial support. And so it's absolutely key to get your application in as early as possible if you are searching for funding to support your education. And why do we need it early? Not only is it for those fellowships, but in order to talk to other faculty and find out whether maybe there is some professor who will be intrigued by your background and may want to pay for some of your time at UC Davis. And in return, we make decisions about financial support before April 1st. So you will receive information about that decision if all goes well, by April Fool's Day. But in general, you need to get your application in by April 1st, and we will make a final decision somewhere around June 1st for all of the applications, depending on if there are some spaces available. Okay, so an important question is, how do we on the graduate admissions committee evaluate your application? So I want to spend just a couple minutes describing the admissions process. What we in the admissions committee do is we collectively make a decision. That is to say, it's not done by a single person. It's not done by me, the chair, or any other person. It's not the responsibility is not divided. The whole committee makes a decision about each student. And in that decision, we examine the totality of your application. That is to say, we look at it holistically. We look at your GPA. We look at the letters and statements. That is to say, your personal statements. And we also are checking to see whether faculty are interested in you. And I'll come back to that in a moment, but that is a key issue. If faculty look at your application and decide, hey, this person looks exciting and is wants to study something that's right up my alley, that will make you a more preferred applicant. So like I said before, we're going to consider admissions and mostly make financial decisions on a rolling basis, but we really have to get in our nominations for university fellowships by January 15th. So once again, if you're trying to apply to UC Davis and want financial support, January 15th is the day that you need to get your application in. Next. Applications are a lot of work, and face it, most of us don't have much experience writing these kinds of applications. So I thought I'd give you a couple tips on how to make yourself more attractive to the admissions committee, and let's just go through them. First of all, the way we've structured our application, you are asked to review some of the professor's research areas, the EGG professor's research areas, and find the areas that attract you, and reach out and try to talk to them. And tell us who you've spoken with, because that information will help us understand your goals. And as I said before, identify the potential funding. Now, also what happens is we circulate these applications to some of the AG faculty, and they typically only look at the ones that mention them in them. And they're busy people, so that makes sense. So if you think that you're a match with some certain faculty, you better make sure that you have mentioned them in your application. And if you are a PhD applicant, you must have a member of the faculty who has agreed to serve as your research advisor. So that means you've got to reach out and not only send email, but you need to communicate with that advisor because they're going to make a commitment to support you. And to be honest, contacting the faculty is both important and challenging. So when you do that, you really should prepare for it. You should read about them, each of the faculty that you're going to contact, understand what kind of research they're doing. You can look at their publications records. Most of them have websites. You can sometimes find other information about them, but be prepared and know that you're talking to an economist and not a physicist or something like that. Don't make that kind of mistake for sure. And then when you finally do reach them, explain to them why you are interested in Davis, why you're interested in them, and demonstrate that you have done that homework so that you have something more narrower to speak about that is actually useful to both parties. And, unfortunately, the faculty are busy, so they may not be responsive the first time or even the second time to your inquiries. So you must be patient and persistent in order to get to them. And I also wanted to mention that your personal history and purpose statements are critical because there's the place that you can explain about yourself in your own way. And they're the two key messages that I think will help us is where if you tell us what shaped your worldview, how did you get to where you are so that you're applying to AG, and maybe where you want to be in the future. So maybe 10 years in the future, or maybe 30 years in the future, or something like that. But this helps us place you and understand what your goals are. Next slide. Okay, so we have these are the key contacts. You've heard from Professor Kendall already. You've heard from me, and you will hear and you will be contacting Anne-Marie Schaaf, who is our wonderful graduate program coordinator. And I think that's all for me. At this point, we're going to switch over to some of the professors to describe their research. Is that correct, Anne-Marie? She's nodding. So let's go to the next slide, please.
All right, I'm going to hand it over to Professor Kurt Karnbluth. Please go ahead.
Hey, thanks so much, Alyssa. So, forget about the hype. UC Davis is an awesome place to come. I'm a professor here. I did it kind of the unconventional way. I built it so they would come, and I managed pretty well. And I love having students here to help me build this thing. I'm a professor in bio and ag engineering. I founded UC Davis Program for International Energy Technologies and D-Lab, and I'm a director of the Engineering Student Design Center. I love to travel, and I like to get my students to travel and work on different kinds of projects. You can hit the next slide. And if you go to my website to see what I'm doing, you'll see that I kind of do two things. One thing is D-Lab, which is all about designing for underserved communities, mostly sort of in the ag, energy, sustainability sector, but we also dabble in other areas. I teach you how to be a good designer and how to do a feasibility study. And then we have a very applied program called Sustainable Campus, Sustainable Cities. And you can hit the next slide. So go to my website, check that out. I have about 8 students a year. Usually about 4 or 5 of those are egg students, and often they're working on projects in the Energy Conservation Office at UC Davis to work on projects, real applied projects. I have these project-based classes. We do lots of applied projects. I also teach design and and prototyping. So if you like to get your hands dirty, I could be a good professor to work with. And we'd like to work on international projects. We have lots of collaborations all the way North Africa and Europe and Asia. You can hit the next slide. And the Sustainable Campus, Sustainable Cities, which a lot of my students are involved in, is involves progress, research, education, outreach. Progress is really about getting UC Davis's energy down to zero net energy and also our carbon footprint down. Research is all about publishing and putting that out there. Education is about the zero net energy class that I teach, as well as other courses, other professors who are teaching. And the outreach is working with our international partners to commercialize this and this technology and these ideas. My approach to education is interdisciplinary and multidisciplinary. So we work on interdisciplinary problems, and we like to have multidisciplinary teams. I am an engineer, but don't hold that against me if you're not one. Do I have any more slides? Oh, I don't. So anyway, please come look me up, check out my website. And one thing I did want to add to what Alan Meyer said was, your experience, what you've done in the world, real projects, I personally look at that very closely on your application, as well as if you're somebody who can bring a new viewpoint, an alternate viewpoint to the group. But thanks a lot. Next.
Thanks so much. Thanks so much, Kurt. That's great. It's really hard to follow Kurt because he's so exciting, everything he does. I'm the chair of this graduate program, but I'm also a professor in civil and environmental engineering. And I just will tell you a little bit about what I do. My expertise is in something called industrial ecology, and we try to look at the technical world, the engineered world, and look at it as if it was an organism or a natural system to try to make it more sustainable. So concepts like circularity come from there, but also life cycle assessment, carbon footprinting, water footprinting, all of that comes from this field. And most of my research is trying to help build, move, or eat within our environmental means. And that's really big. That kind of probably is exaggeration of what we actually can do. But you won't see energy listed there because I work a lot with energy, but in the context of how we use it. Right? So we use it in buildings, we use it in cars, we use it in transit systems, we use it when we grow food and process food. And so all of those ways that we use energy is how I interact with energy. And so most of my work right now focuses on electric vehicles and batteries, as well as some agricultural systems and residues. Those bioenergy is probably the most sort of energy related part of that's directly about energy, but we also think about sort of the energy embedded in food as well. And then I have some other work that's probably too far away for ag students, but we think about essentially geotechnical systems, what we do underground to build the world above. And oddly enough, there are always connections, right? So there are always connections between these things. Just as an example, in the geotechnical work we did, we look at dust mitigation for construction sites. Guess where else we need dust mitigation? We often need it around like solar panels. So we end up with some real connections that we don't expect to make even in those cases. And I teach one of our core classes, which is EG 201. It's life cycle assessment for sustainable engineering. I'm also run a graduate certificate program in industrial ecology. I happen to know that it's really easy to get that certificate if you do EG because the core class is the same for the both of them. So, so it's not a big lift to get that. And for some of you guys who know about industrial ecology or learn about it when you're here, it may be something that you want to add to your portfolio or resume. I don't have as much information here, except I do want to talk about the core area of my work around life cycle assessment. It is one of the core classes you will take. And I'm going to talk about it in the context of vehicles because that's where a lot of my work is. But basically, you know, when we think about where impacts happen and where energy leads to impacts, we can often think about, well, historically, we could think about how we use energy. So we burn gasoline in a vehicle. It leads to climate pollution, right, climate change emissions as well as air pollution. This slide is kind of busy, but it basically thinks about how do we change that energy story. And a lot of folks said, well, what about biofuels? Maybe we can do something about biofuels. And so maybe we can move away from gasoline and make a renewable fuel from biofuels. And we need life cycle assessment because it turns out if we actually do the whole analysis of the carbon footprint, the environmental impact, things like that, biofuels don't always look good. And if we don't think from a life cycle perspective, we might just say, hey, we've got, carbon from the atmosphere going back up there. That looks like a net zero energy choice, and when it's not. And the same goes for electricity and hydrogen. It matters how we make it. And so a lot of the work that my group does ask questions around that. How do we transition away from fossil fuels, for example, and do it with a no regrets outcome, or at least as few regrets as possible. So a lot of our work right now, for example, on electric vehicle batteries has to do with how we make them, how we get the minerals out of the ground, how we dispose of them, and how we do that all, hopefully, in a way that is more environmentally sustainable and leads to a more equitable future, that we're not burdening historically burdened populations with the impacts of our new energy system, right? And yeah, I don't even know if I need to talk about this, but I did want to highlight, these are work done by some students in the energy graduate group. And this one focused on thinking about the future and how much circularity we could have in battery materials, meaning how much of it could we get from our own batteries that we recycle, and looking out to the future, that we might be able to get about half of our materials from recycled batteries if we're able to actually set that infrastructure up and collect them. But added to that, we're looking at some of the impacts of producing these materials and thinking about it from the standpoint of the communities affected by mining and extraction. And so thinking about that big energy system, the people who need the energy, the people who are impacted by how we make it. And in this case, it's just an energy technology, but it's the same idea. So I'm going to hand it to Professor Kelly Kissock, who is the faculty director of our Energy and Efficiency Institute, which is where our graduate group lives, and also a professor in mechanical and aerospace engineering. Kelly.
Thank you, Alyssa. Welcome, everybody. Alyssa got my name right. It's Kelly. When I reflect back, I think I became interested in energy and the environment when I was in high school. I'm going to guess that some of you had early interest in this area, and you're continuing to pursue it now. But the issues, the challenges, and really the opportunities to build a better and more equitable and more sustainable future, a whole bunch of them revolve around energy. So you get involved in this area, and I think our graduate group is a great way to do it. You can be part of something really big and really important, and I'm pretty confident it's going to be a really positive too. So Marie, do you advance, or I don't have, is that me or you? Okay, you're the advance. All right, so here's some of the areas that we work in. And that is, I've spent a lot of time working directly with industry, going around and working inside plants and helping them to become more energy efficient and less carbon intensive. And we're continuing that work, for lots of years. Lots of us were working to make the world more energy efficient. And that was good because we reduced pollution, and we made the businesses and houses and everything more competitive and things. And increasingly, though, our focus is on decarbonization. So that work's continuing. We work with Lawrence Berkeley National Labs and DOE centers all the way across the country in making industry more efficient. Next. I just wanted to share with you some of the ways we're working to make industry more efficient. And one of those is just not only to change how much electricity they use, but when they use electricity. So it turns out that in California and increasingly in other places, more and more of our power is coming from the sun. And so during the middle of the day, we have a lot of electricity, and the carbon intensity of electricity is very small. And if we can get industry and buildings to use their electricity during these periods, and not so much at night when we're burning more fossil fuels, there's enormous cost and enormous CO2 savings. So this is one of the areas that we're working on, and I'd be pleased if you would come help us. Next slide, please. Another area we're working on to help decarbonize the world is to phase out the use of fossil fuel combustion, and including in industry. And a whole bunch of the natural gas that we burn when we make things is just to heat water. And we're figuring out that we could do that using electricity. And when this electricity comes from the the sun and the wind as it increasingly does, we can dramatically reduce our carbon footprint. But doing that requires some smarts, some thinking. And the thinking here is we're going to take heat out of some processes that where we're throwing it away, and we're going to turn it into waste heat, into the kind of heat we can use for buildings to replace boilers. So this is called process integrated high temperature heat pumps. It's an exciting part of this future. Next slide. And just as before I came here, I worked with a lot of industries. We're continuing to work directly with industries, and it's fun. It's fun to be part of this. This work we're doing here is from a cheese plant. It's not just a little cheese plant, it's the biggest cheese plant in the world. And so just like Kurt, you get an opportunity to be hands-on, be in these plants, talk to people, solve real problems. Next slide, please. We're also working on this new fuel called hydrogen, potentially new fuel called hydrogen, and it's working on where it might be used in industry and where it might be in buildings. One of the things we're thinking is that hydrogen it's hard to transport. It's really a light molecule, takes a lot of energy. So we're looking at what they're called industrial clusters of industry which are close together, that might be good candidates for using hydrogen produced locally. And in buildings, we're looking at using hydrogen in fuel cells. Fuel cells take hydrogen in to make electricity heat off the backside. And so buildings that require both electricity and heat, like hospitals and hotels, really good candidates. It's another area we're looking at. Next slide. And I can't remember the slide. One more, and we're also working in the building space. A lot of really exciting things in big buildings that have lots of zones. Typically, we have chillers to cool them, and we have boilers to heat them. And people have done some work that we're part of this team, and says maybe only 17% of all the energy in the natural gas goes to being effectively used as heat. And so we're figuring out better control systems in these buildings. And this is also a really important area, energy informatics and data analytics and data-driven controls. If you get involved in this, you will work forever very productively. Next slide, please. I think that's all. So thank you very much.
I guess it's me again. Yes, this is Alan Meyer again. So I'm an adjunct professor in the Environmental Science and Policy Department. In that department, I recently taught a course in international energy policy, and we explored the different kinds of international agreements related to energy and the environment, leading up to, of course, the most recent Glasgow Agreement. But we also worried about the aviation emissions and how do you reduce aviation emissions. But I most often try to teach a course called Fundamentals of Energy Efficiency, where we introduce some of the key underlying principles and a sort of framework for understanding how energy is used and how it can be saved. I'm also a scientist at Lawrence Berkeley National Laboratory, where I lead a group called the Electronics, Lighting, and Networks Group. And that's where I do a lot of my research. And with luck, we'll start bringing more of the graduate students from EGG to Lawrence Berkeley National Laboratory to work with Professor Kissack, who also has an appointment there, on some of the projects supported by the Department of Energy. Next slide, please. So I'm not going to be able to describe too many of these projects I have, but before I even go into this one, I want to talk about dust, because Professor Kendall was describing the problem related to dust on the efficacy of solar photovoltaic collectors. Well, we found that in a project that we had in Dubai, where we were studying a sustainable community and trying to understand how the behavior of the occupants or the residents of this community affected the sustainability. one of the key elements was, how do you keep the collectors clean, and what sorts of behaviors are necessary by the occupants, by the managers, and even the designers of the community, to ensure that we get the maximum efficacy from the solar collectors. So dust was important from a technical aspect, but also, and this is an area where I study, a behavioral aspect. I'm going to talk about three projects. Even before I get to this one, a lot of my work at Lawrence Berkeley National Laboratory was based on the realization that many devices and appliances consume electricity while they're not only switched off or not performing their primary function. And we call that standby power consumption. And a while ago, actually a couple decades ago, we began to realize that that was a significant amount of electricity, not only in each home, but globally, and corresponded to about 1% of the global carbon emissions were due to these appliances, whether it's a television, whether it's a sound bar on a television, a computer, whether it's your gaming, your Xbox. Practically everything now has standby power consumption. All of that was adding up and responsible for an important amount of electricity that was mostly being ignored. And so one of the projects that I started was to realize we could reduce standby power consumption significantly. I proposed a plan, a kind of a global plan to reduce standby power. And much to my surprise, President Bush decided it was so important, he signed an executive order, basically putting into administrative regulation what I had proposed. I've done a lot more, but that's probably where you'll see most of my work. But now I'm going to talk about two projects that are ongoing. First one is putting unoccupied buildings to sleep. And this is based, again, sort of on the standby principle, that if we look at many buildings, and that is both commercial buildings and homes, we'll see that the miscellaneous electrical loads, that's the not heating, not lighting, not water heating, not cooling, not refrigeration, it's those other miscellaneous loads, are now responsible for something like 30% of a building's energy use. And many of them are simply ignored. And what we found, especially in commercial buildings, is that that contrary to our expectations, that which would be as a building gets more and more occupied, the energy use should go up. And in the opposite direction, as it gets closer and closer to vacant and unoccupied, the energy use should go down. That's not the case. We found that as the building got emptier, the energy consumption didn't change much. And probably you noticed maybe in your campuses and maybe in your offices during the pandemic, the electricity use of the building hardly fell, even though nobody was in the building for 12 months. And this made it very obvious to people that we really needed to understand how to make building energy use more flexible and more responsive to the number of occupants. So we've been trying to figure out ways of first identifying when a building is empty, because we think that's the key, an important area, when exactly the building is empty, totally without people, and then take even more aggressive measures to reduce energy consumption than has been taken so far. And so in order to do that, you have to identify when the building is empty. And this is where we're creating at UC Davis what we call a vacancy inference engine to draw upon all these different sensors that are now in buildings, use principles of sensor fusion to combine that information and to get a prediction of the and a confidence that the building is actually empty, and then disseminate that information to various kinds of miscellaneous electrical loads so we can switch them to what we now call a vacancy mode. And that's one of the research areas. Let me go to the next one that we're working on. Thank you. So I've been involved in thermostats for quite a while. It turns out that if you look at all the thermostats in homes in the United States, they control about 10% of the United States energy consumption. And if you've ever tried to program a thermostat and you get frustrated, you'll realize that most of that energy consumption is poorly controlled at best. And so I've been working with the Energy Star to certify more energy-saving thermostats. One of the things that came out of this, however, was that with the new internet-connected thermostats, you can learn other kinds of information. So, for example, when the Nest or the Ecobee thermostats stop receiving a signal from a home, there's a good chance that the power went out. And so we've started using the thermostat connections or more precisely, the thermostat disconnections to track power outages during events like hurricanes in Florida and other kinds of great large storms. And it turns out you can learn a lot that way that the utilities don't know, because these thermostats are present in across many states. So for large kinds of climate catastrophes, if you wish, the thermostats are better than better sources of information than individual utilities. But then we discovered that the cable companies had something even better. And so now we're using the cable companies to collect this data about when there are outages in individual neighborhoods of 250 homes or so. And they collect that information without interfering with people's privacy. And they also provide additional information about the voltage of the grid in each neighborhood. And that becomes very important in the future, because with the introductions of photovoltaics, batteries, and electric vehicles, and now electrification caused by decarbonization, there's going to be much more variation in the voltages in neighborhoods, and we need to track that before the transformers blow and we run out of capacity in certain neighborhoods. And so suddenly we now have the situation where the cable television companies know more about the electricity consumption in their in neighborhoods than the utilities themselves. And so we've been working on trying to bring that information from the cable companies to the utilities. I think I'm going to stop there and go to Professor Hernandez.
Hi, can you all hear me okay?
Dan.
Sure can.
Great.
It's all yours.
I'm not in my office, but I just couldn't miss seeing all of you prospective egg students, and I'm so excited that you're here joining us for this open house. Energy, as you know, is such an interdisciplinary topic. It ranges from engineering to policy, but also to the environmental sciences. So the work that my group does falls into this intersection between energy and the environment. But ironically, it seems as though what really unites all of us today is dust. It seems like everyone has mentioned this topic. We're, in fact, are also interested in dust. We're interested in dust owing to the disturbance of very fragile desert soils and how that contributes to issues related to performance and impacts on ecosystem services. We're also interested in soiling in general from birds, as it turns out, which can be a driver of soiling in photovoltaic solar energy installations. Those are PV installations that are installed over constructed bodies of water. But I digress. So my name is Rebecca Hernandez, and I'm an associate professor in the Land, Air, and Water Resources Department. I'm also the director of the Wild Energy Initiative. And, you know, I started as a geographer and a biologist in my undergrad. I ended up getting a master's in biology, and then I worked in between those degrees and subsequent ones, but I got interested in energy because I was doing conservation work in the desert. And it was clear that we were prioritizing these large solar energy installations in these very sensitive and important ecologically ecosystems. And that really kind of springboarded my entire research program in studying energy and environment interactions. And that's what I ended up focusing my PhD on. My PhD was in Earth Systems Science. And one really important aspect of that work was simply answering the question, how much land do we need for big solar, those large, very displacive ground mounted installation? And that work has now led to subsequent work in understanding environmental impacts, but also benefits that can result from how we deploy our energy infrastructure. Next slide. So our team, we really see our work as something that addresses some of those critical implementation gaps. That is, how will we're really interested in providing science that helps folks make the most sustainable decisions, especially as it relates to siting and site preparation. But ultimately, our driving, motivating question is, how will we meet our rapid renewable energy goals while still maintaining our goals for conservation and for feeding the planet? And this really is what we think is the most important environmental challenge of our time. And so that question is what unites us all in this initiative. And we seek to bring together folks that are interested in this topic, specifically on the interactions between energy development and planet Earth, including all of its systems, the biosphere, the hydrosphere, the atmosphere, and its species, to address these really exigent sustainability issues. Next slide. One of the ways that you can get involved is we've started a fall seminar series that runs alongside the energy seminar series, and this one's called the Wild Energy Fall Seminar Series. And this series is framed around these same topics at the interface between energy and the environment. So we had our first implementation of this in fall of 2021, and our plan is to have every other year be a little bit different. So in odd years, we're gonna invite the scientists and scholars who are working in universities doing research on this interface, and then switch it up in even years to bring in practitioners, those who are working at this interface in places like for NGOs, industry, and government. But this year was a huge success. We had over 20 students that were enrolled in this particular seminar series, and we discussed everything from climate change mitigation to biodiversity as it relates to energy, to socio-ecological outcomes owing to renewable energy development, like impacts on public acceptance and sense of place. So it was really rewarding. Next slide. Yeah, so some of the research topics that we are interested in my lab range from, as I mentioned before, siting. Where are we going to put all of this renewable energy infrastructure, looking at things like public acceptance. A lot of the work that we've done has been focused on understanding how solar energy impacts species. So that includes not only animals, but also plants. We actually study how plants might be impacted from the shading from solar energy, or the displacement of precipitation that would otherwise fall and hit the soils and help initiate germination. And we're also interested in end of life. What happens to all of those hundreds of millions of solar panels at the end of their life, when they're no longer generating the electricity that they once did. And we also are really interested in understanding how all of these things work together to either reinforce or perhaps undermine our sustainable development goals, our UN sustainable development goals. Next slide. So a little, just a quick overview of some of the research projects that we have going on right now. We have a DOE funded project that looks at the performance, the hydrological and the ecological aspects of floating photovoltaic solar energy. So here in the upper right, you can see Alex Kegel. He's one of our grad students in AG, and he is dropping a sonde that's measuring a suite of water quality parameters right under the solar panel that's covering up a stormwater reservoir in Orlando, Florida. And not only does he have to sort of make sure he stays balanced on that plastic float that he's sitting on, but he also has to be careful not to come too close to any alligators or otters, which actually can be a lot more dangerous than the alligators. Another project that we have on the docket coming up is thinking about how we can site smart for species when it comes to renewable energy. So we all know that species ranges are decreasing owing to habitat loss, but they're also shifting owing to climate change. So how can we anticipate the future conservation risks and opportunities for species when it comes to planning for a massive US rollout of renewable energy? And last but not least, we're also interested in stacking solar energy with ecological systems. So how can we layer solar panels on top of ecosystems? So we're doing that work here locally at the UC Davis Solar Energy Power Plant. And we also have a collaborative partner that I can't name right now, but it's really exciting. And we're going to be doing that same work with them. And eventually our goal is to make an entire California prairie ecosystem underneath an operating solar energy power plant. So we're really excited about that too. I think that's it. Please feel free to email me if you have any questions, rrhernandez@ucdavis.edu. Thank you, colleagues, too, for letting me join in.
Yeah, thanks so much for making it. I know you're on the road, so we really appreciate you taking the time to talk to everybody.
I wouldn't miss it.
All right, so I think at this point we want to make sure that the folks, the prospective applicants to AG who've logged on have time to talk to some of the students who are here. So just reminder of key dates that Alan Meyer did a good job of talking to you guys about. So January 15th, April 1st, and June 1st is the final deadline. I would treat April 1st as the final deadline, all right? Because by the time we've passed that date, we aren't really looking at new applications typically. I think I wanted to just say one thing to students here. The application process for PhD students, keep in mind you do need to have a faculty advisor, meaning you need to be reaching out to faculty now to say, hey, I'm interested in being a PhD student in the EGG program, et cetera, et cetera. Master's students do not need to do that. You can apply and be admitted without any kind of faculty advisor. If you want to do a thesis during the time that you are here, you will need a faculty advisor. But for master's students, there is no requirement that you find a faculty to work with. As Professor Meyer pointed out, it's great if you have somebody who's already advocating for you. But as a master's student, it's absolutely not required. You can submit your application and be admitted without any contact with faculty members even. Not that I'm encouraging you to do that way, but I just want to be clear that you don't have to have a master's. I mean, you don't have to have an advisor, a faculty advisor, to be admitted as a master's student. In fact, you don't even have to have one to graduate. You can do a coursework only master's program. You don't have to do a thesis here. Here is a list of a partial list of energy group, graduate group faculty. Please check out our website. All the faculty are there, and you should be able to see their contact information too. So you can read up on what folks are working on and what you're interested on. You're also welcome to reach out to Anne Marie and Alan and me and any of us, and we can try to help out as well if you're contacting people and not hearing back. So it is now time for the faculty and staff to hand this over to students and alums so you guys can ask your questions. We have Brianna. Let's see, I know I saw you earlier, if she's still on. There she is. Hi, Brianna.
I'm here.
Great, nice to see you. We've got Mina,
Hi.
Ashley,
Hi, Alyssa.
hi, Yemi. I saw Yemi earlier, so hopefully he's still on. And then Jess.
Hi, Alyssa.
Hi there. Okay, we also have one alum, Armando. Thank you so much for joining us.
Of course, yeah. Good
All
afternoon.
right. All right. So I think Anne-Marie, I think you're maybe in charge here. So maybe you can hand it over to one of the students, or you can
Yes.
hang out quietly.
So I'm gonna stay connected just to make sure we don't disconnect.
Yeah.
But I am gonna step away and not be listening so you guys can have casual conversations. Ashley Depew, you are a co-host in case you need hosting ability to do whatever hosts need to do. But you guys are welcome to chat. The program goes until 3:30. So you have about 20 minutes.
Yeah. And just, I don't see too many people logged on. So for those of you who are here, if you can turn your cameras on, I think that would be really helpful. And, you know, make sure that you introduce yourself a little bit so people can ask questions in context. So where are you logging in from? What are you interested in, a master's or PhD or not sure, that kind of thing, so that the students and alums can really respond in ways that are helpful to you. So I'm going to take off. And it's nice to virtually see your names up here. Cynthia, I think you were in my ECI 123 class, so it's nice to see you back. And you're welcome to get in touch, of course, if you have any questions. And I'll sign off now.